Hi there, this video is to go over the pre-class reading for Class 7. It starts with section 3.4, Inertial Reference Frames and Newton's first law. And it starts off by just talking about how I think someone accelerates their car, and there is a coffee mug sitting on the dashboard which falls. And so they ask you to kind of analyze the situation looking from two different reference frames or different perspectives. So one is that you've got an observer who's in the car, and the other is that you've got an observer sort of outside the car that's watching this from the stationary Earth. And there's a nice little video you can click on there. This is the view from inside the car. It just falls. What's going on? And this is the view from outside the car. The car is moving, and it's actually the bottom of that cup is being pulled along, isn't it? So this leads you to the idea of reference frames. There's a vocabulary. The inertial reference frames are ones in which they're moving at a constant velocity, and non-inertial reference frames are reference frames that are accelerating. And so Newton's first law of motion is that if you're in an inertial reference frame, when no objects exert forces on a system, or when the forces exerted on a system add to zero, the system will continue moving at a constant velocity. And a special case of that is it could remain at rest. There's a thing of Isaac Newton. Now, section 3.5 actually goes through some experiments that are quite similar to what you're going to be doing in the second week of practicals. The first thing you imagine is changing the force on pulling a cart, and looking at how that changes the acceleration. And then you keep the force the same, but you change the mass of the cart and look at how that changes the acceleration. And that leads us, if you look at both of them, so basically more force for the same mass gives you a greater acceleration, and the more mass for the same force gives you less acceleration, and it all gets summed up in one equation, if you keep scrolling down, called Newton's second law, also the title of this section, which is the acceleration of a system is equal to the vector sum of all the forces on the system divided by its mass, the system mass. Vector sum of forces, sometimes people call that the net force. Okay. There's a lot of examples of this. So you have to usually draw what's called a force diagram in order to find what the vector sum of forces are. So that's an important skill here. And this last section is going to give you an equation for the gravitational force. It's here. It's a bit of a strange looking equation. It says that the force of Earth on an object equals the mass of the object times g, where g equals 9.8 newtons per kilogram on or near Earth's surface. So that's basically the equation for the gravity force. So that's it for the reading. I think what I wanted to do is just at the end of this video, just quickly talk a bit about question 1. You are standing on a bus this is from the pre-class quiz today, that a pedestrian sees moving at a constant speed of 35 meters per second, and you toss a coin into the air. So in your reference frame, in the bus, the coin goes straight up and falls straight back down into your hand. So this is about reference frames. There's another reference frame, which is the pedestrian, just watching the bus and you go by. And you need to, in this question, think about sort of separating out horizontal motion versus vertical motion. And the question is, while the coin is in the air, what does the pedestrian see as the horizontal speed of the coin? Whereas in your reference frame, since it's going straight up and down, it has no horizontal component to its speed. So I hope that helps. And all right, I'll see you in class on class 7. Bye for now.